Hey y'all, it's me, Miss B. Today we are on day 2 of our 2.4 notes. That's not right. 2.4 notes, which is synthetic division and long division. But today we're using the remainder theorem and the factor theorem. Okay, the remainder theorem is basically saying that if something's divided by x minus k, then the remainder is going to be r equals f of k. So I'm going to use, basically what it's saying is you're evaluating the function and then you get the remainder. So if I'm, if it might say like find the remainder of this function if the factor is x minus 4. So let's go ahead and jump in. So we're going to plug in 4 for our divisor here, and then right out here. So we have 3, 4, -2, and -8. So basically what it's saying is if 4 is a factor, then this remainder is going to be equal to f of 4. So let's go ahead and do that math. So let's drop the 3 down, multiply by 4, add, multiply by 4, add, multiply by 4, and add. So 240 is our remainder. Let's go ahead and look at what f of 4 equals. I'm going to go through it somewhat quickly. So wherever there's an x, we're going to plug in 4. All right, so we get 192 plus 64 minus 8, which if you add those all together, we get -16, 64, so this is 240. Okay, you can check my math on that, pretty sure it's right. Okay, so you end up getting 240. So if you use the remainder theorem with this right here as your factor, then you will get that out. So that's why it says r equals fk. So it's 240 equals f4. All right, next up, let's find f of 3 by using the remainder theorem. So I'm going to plug 3 in here. I'm going to have 3, 5, 10, and 1. Drop down the 3. We get 3 times 3 is 9. Add, we get 14. 14 times 3 is 42. Add, and we get 52. Multiply 3 by 3. I messed up somewhere. Oh, this should be a -10. So this is actually 32. Times 3 is 96. Add, and we get 97. Okay, so f of 3, because our 3 is here. F of 3 is equal to 97. All right, factor theorem. Basically what that's saying is a polynomial has a factor of x minus k. Only when f of k is equal to 0 or your remainder is equal to 0. right, there's a few things that come along with that. So if r is the remainder when f of x is divided by x minus k, then f minus k is a factor. And x minus k is a factor of f of x. All right, it also means that x equals k is an x-intercept. And it allows us to factor polynomials with exponents greater than 2. All right, so let's jump into this example. So it says show that x minus 3 and x plus 1 are factors of this function. So I'm actually going to do synthetic division more than once. All right, so let's go ahead and do x minus 3. So we're going to do x minus 3 is equal to 0 and solve. So I have 3, and then I'm going to put 1, 6, negative 3, negative 56, and negative 48. There's my line. And we're dropping it down. Rewrite that line. All right, so drop down the 1, multiply by 3, add, multiply by 3, 27, add, multiply by 3, add, multiply by 3, and add. So we get remainder 0. So yes, x minus 3 is a factor. All right, so then we're gonna, instead of starting over, we're gonna keep going. So I'm gonna go ahead and do my x plus 1, so my other one, x plus 1 equals 0, and solve. So there's negative 1. I'm going to move this up a bit. Okay, so I'm using my last factorization right here to do my next part. So dropping it down, get 1. 1 times negative 1 is negative 1. Get 8. 8 times negative 1 is negative 8. 16, negative 16, we get 0. So yes, x plus 1 is a factor. Okay, so what that means, that x minus 3 and x plus 1 are factors, is that we can write this as basically x to the 4th plus, I'm not going to rewrite this whole thing. So this whole thing right here, our original equation, is able to be written as f of x is equal to, we're going to write what's left over. So this was started out as x to the 3rd, which dropped down as x squared, which dropped down to just an x. Oh, this is x to the 4th. Oops. I'm mistaken. This was x to the 4th. Oh, dang it. X to the 4th, x to the 3rd, x squared. So we get x squared plus 8x plus 16 can be multiplied by x minus 3 and x plus 1. And then we want to factor it a little bit further by factoring this piece right here. So the way we factor that is two numbers that add to be 8 and multiply to be 16 are x plus 4 and x plus 4. So this right here answers the question of complete the factorization. Okay, so this right here is our final answer to that. Okay, so just to go through, we use synthetic division all the way down, then we factor it the rest of the way.